In this video, we're going to talk about how to solve a quadratic equation. So very similar to finding our x-intercepts for a quadratic function, but now we are not dealing with the graph. We don't need the graph. We just want to know when are these two things equal. This could be done with a graph, but it's simpler to just solve the equation in this case. So first we need to do is, if we want to solve this by using the quadratic formula or factoring or even the square root principle, we want to get our equation to something preferably that looks something like this. Then we could use the quadratic formula. We could think about factoring if it does indeed factor, but no matter what, this is sort of our goal because I know how to deal with this. That's like solving for the intercepts. I don't know how to deal with the giant mess that's here. And so I basically grabbed one of the hardest questions from a book I have as an example. First thing we would do, maybe do some distribution, both on the left side. We have this 11 to distribute, nothing to distribute to the second parentheses. If we think about imaginary 1 there, we could distribute it, but that's unnecessary. But we do need to distribute on this second side as well, on the right side, where we have our little binomial times a binomial. And this is where the quadratic nature of this is going to come in. Because over here we have linear terms, and over here we're going to see there's going to be an x squared. So if we work through this, we have 11x minus 22. I'm going to go ahead and drop the parentheses since it's not really doing anything for us in that second binomial. And then this is all equal to, we got x squared minus 6x plus 2x minus 12. Might as well combine our like terms on both sides before we go set aside equal to 0. So it looks like we have 12x minus 27 on the left-hand side and x squared minus 4x minus 12 on the right. Up to you. It does not matter which side we set equal to 0. I personally like the fact that our x squared has a 1 as its coefficient, so I'm going to make the left side of this equal 0. I'm going to subtract off 12x and add 27 so that those will cancel, and I'll do the same thing on the other side of the equation so that I'm being fair and put them under their like terms so that it's obvious what's happening. So now we have 0 is equal to x squared minus 16x plus 15. And now we have two ways we could solve this. First way is, if we're clever about this, we can think about, does this factor? This particular question does, right? What multiplies to a positive 15 and adds to a negative 16? Well, x minus 15, x minus 1, right? That is the exact same thing, just written in a factored form. And this is all 0, so that means x is either 15 or x is equal to 1 using our 0 factor property. Now, there's no guarantee this will happen, so I'm going to go ahead and redo this in the method that will always work. Once we get down to this 0 is equal to our standard form of a quadratic, we can always use the quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And then we just need to figure out what's our a is 1, what's our b, negative 16, what's our c. Once we have all three of those things, we can plug into this formula. So we have a negative 16. This time I'm just going to change that to a positive 16 plus or minus negative 16 squared. A negative squared is just going to be positive, so I tend to be lazy about this when I type it in the calculator, and I will actually just type in 16 squared because I know it's the same thing. Minus 4 times 1 times 15 all over 2 times 1. So I'm going to go ahead and do this on my calculator. I didn't mean to move it. So I have 16. Oh, I guess I need my fraction. 16 plus the square root. 16 squared. Number, I realize squaring a negative is going to be positive, so I can just square the positive version. Minus 4 times 1 times 15. You can do the parentheses so it looks just like what you have written here. Or you can just realize it's all multiplication and use the multiplication symbol. And this is all over 2. The plus version of this is equal to 15. The minus version, what does that give us? Let's go ahead and rebring this in. I'm going to change this to a minus. And we get the one that we knew that we had in the original one we factored. So this is what it'll look like for us if it factors nice and beautifully. I want to show you guys one last thing before I free you, and having done this one example. Remember, the x-intercepts of the last question are another example, so you can always look at that. And you have, I think, 5 of them in the old exam that you can check out. But I did want to show you there is a calculator shortcut. Now, I don't want you to just use the calculator shortcut, but this will allow you to check your work on the test. So, if you've made it this long in the videos, you're going to be the only ones to know about this. So you see in your calculator, it actually has something called a polynomial solver. And a quadratic is a polynomial of degree 2. So this thing will solve polynomial equations, including quadratics, for you. So if we press second, and then this button that says Poly Solver above it, it asks, what do you want to solve? Do you want to solve something that fits into this format that we were talking about? Or do you want to solve something that has a degree of 3? Now, we just want to solve quadratics in this one. So we press enter, it asks us, what's our A? What's our B? And what's our C? And if we press solve, it tells us the first answer is 1, and the second answer, is 15. So it'll even give you the nice little decimal versions when you're solving for your functions. What do I want to see from you guys on the test? You need to at least plug everything into the quadratic formula. This needs to be on your test, even if you go and just grab the 2 answers from the quadratic solver. But you have to at least write this piece down to get full credit. So there you go. That's solving quadratics and how to do so really quickly with a calculator.